0. Okay, hey everybody, your man Robert Wolfert here, and welcome to today's video of a random Linux tool explained. Yeah, it's again about Linux tools, Linux command line tools you can use for day-to-day work, and I want to explain some of these tools for you, and so you get perhaps or hopefully some interesting insights and some useful tips. And for me, I've added a challenge that I'm not prepared at all what tool I have to explain. Instead, this tool is randomly chosen, and therefore the name a random Linux tool explained. So let's start directly with sharing my screen. Okay, you should see it, and I'm again in the directory where I have the file tools.txt. This file contains all the tools from the shell toolbox, and this is the script that chooses one single tool randomly from these tools. So let's have a look at the tool for today. Choose tool.sh, let's run it, mixing the tools, and voila, the winner is today WC. Okay, WC is a really simple command for counting. WC is a great example for the phrase or for the philosophy, do one thing and do it well. There are on a Linux system really many tools available that can only do one single thing, and they can do this one single thing really well. So let's have a look at the WC tool. The WC tool is a tool that counts something. The WC tool counts by default the input data stream. So let's simply start the WC tool here. And what's going on here? Let's make the picture a little bit larger. Okay. So the WC command now reads in data from its input data stream, and the input data stream is now connected to my keyboard. So the WC command simply reads in what I type in. So I type in just hello WC command. This is a second line and a third one. Okay, and if I'm ready, I need to tell WC so how can I do this? If I hit Control C at this time, then I would terminate the WC command. Instead, I need to mark the data stream, the input data stream, as this data stream has ended. And how can I do this? I simply hit Control D. I hit Control D, and Control D sends an end of file or an end of data stream, if you like, marker within the data stream. And now the WC command sees that the input data stream is over, nothing more to read in, and it prints out that WC has read in 3 lines, 11 words, and 53 characters. Let's count this or verify this. 3 lines, we have 11 words, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and 53 characters. I don't want to count them here. So this is what the WC command does. What can you do with this? For instance, you want to see how many files are within the current directory. How many files are within the current directory? I can do it simply by just calling ls, pipe the output of the ls command to the WC command, and give it the command line option -l. Within the current directory are 3 files. Okay, what does this command line do? First, I tell the wc command, please only count the lines. -l stands for lines. If I want to count the characters, for instance, I would call, sorry, my keyboard, yeah, I would simply call wc with -c, yeah, count the characters. Hello world contains 12 characters. And if I want to count the words, simply use the W. Yeah, so WC reads its input from the input data stream, and I simply can pipe the input data stream from a command just before a WC command via the pipe sign, via the vertical bar. Yeah, WC reads in this data and WC prints out the result. Yeah, if called without any parameter, then WC would count the characters, the lines and the words. And if I'm only interested in the lines, in the words, in the characters, yeah, just use, or I just use the parameter for this. Now the ls command, yeah, gives me, if I print it out, ls here gives me these 3 entries. Yeah. And if I pipe the output of ls to the wc command, then ls will simply count the lines. What? WC counts the lines? I have only one single line. I see only one single line here. What's going on? What's going on? Why the 3 at this time? Yeah, really simple. ls knows that the output isn't going here to a terminal. That the output isn't going to a terminal. If the output of ls goes to a terminal, then the ls command will simply, yeah, format the output. Do some colorings and do some columns and print out a table. But if the output doesn't go to a terminal, then the ls command will simply print out each file on a single line. Yeah, let's prove this. Let's prove this. Oh, let's switch off and on my keyboard again. I have a really huge latency here. Now, better. Okay, let's prove this. Let's prove this. Let's call ls. This is the output ls gives me to the terminal. Let's redirect the output to a file, for instance, list.txt. Yeah, what you see now is that list.txt contains line by line all the files within the current directory. Yeah, not in one single line, but line by line. Let's do a different way, or let's take a different way to prove this, that the ls sees that the output isn't going to a terminal. Let's simply pipe the output to the cat command. The cat command is a command that can read in the data stream from the input side and print simply out the same data stream to the output side. And let's see what happened. Yeah, cat reads in line by line the output of ls. So this is the data as the wc command sees it. Yeah, so I can simply use the wc command here to count the lines within the output. Yeah, so I have currently 4 files within the current directory. Yeah, files or directories. Okay, you can use wc for everything you want to count. Let's say I want to count how many users are defined within the current system. Yeah, how many users are defined within this file etc passvd. How can I do this? Simply I could print out etc passvd with the cat command and then pipe everything to wc-l to count the lines, or I could avoid using the cat command here, because if I give to the wc command parameter without a leading dash, then this would be the file that the wc command takes as an input. Yeah, so simply let's count the lines of etc passwd this way, and let's count the lines for etc group in this way, and let's count the lines for etc shadow too. Okay, now for etc shadow I don't have any permissions for, but I could use etc profile, for instance. Yeah, and now you see I have 34 lines in etc passwd. I have 34 users defined for the current system. I have 60 lines in etc group. I have 27 lines within etc profile, and in total we have counted now 121 lines within these 3 files. Yeah, okay, this is the wc command. Yeah, if you want to count something, use wc. Typically used for counting processes. Yeah, how many processes are running on a system? Yeah, wc-l for the output of psax. Yeah, you have to reduce the scene number here by 1 because the output of psax gives you a headline for the table of the running processes. But I think you've got the point. Yeah, if you want to count something, it doesn't matter if this something comes from a data stream, yeah, from the output of a command, or if this something comes from a file directly, as within this example here. wc can count the lines, wc can count the words, and wc can count the characters, the bytes. Yeah, wc-help shows you all the information here. You have characters, the bytes and the characters. If you use -c, we count the bytes. If you use -m, we count the characters, because some characters can consist of not only 1 but 2 bytes, for instance. Yeah, so -c doesn't count the characters. To be exact, -c counts the bytes and -m counts the characters. Okay, so this was the first tool. First tool was wc. Let's take another tool. Let's go to the script and let's call the script, choose tool.sh, mixing the tools again, and now the winner is service. Okay, the command, the tool service is a tool for controlling the running services on your system. If you are on a Linux system, then you could, or then you need some tool that controls the running services on your system. This is typically the process with the process ID 1. So let's have a look into the output, or for the ones tuning in lately. Now we talk about service. Yeah, I hope this can be seen now. Service. Yep. Okay. If you have a look at the output of psax, and I'm only interested in the first lines here, and then you see you have a process with the process ID 1, and this is the process that controls everything that's going on the system. All the services that are running are typically started by directly or indirectly via or by this process with the number 1. Yeah. If you would have a closer look, let's take the tool ps3 here. The tool ps3 gives you a tree of all the processes on the system. Yeah, ps3. Well, ps3. Yeah. Let's scroll a little bit up, and you see the first process here, the systemd, the system daemon, is the parent process of all the other processes running. Yeah? And the systemd perhaps has started this tool, the ACPI daemon, and perhaps it has started the accounts daemon, and this accounts daemon has then started the gdbus daemon, for instance. Yeah. Okay, so there are a lot of services on the system running, and the first started process controls them directly or indirectly. Yeah. So if you wanna control this, you can use the service tool. You can use the service tool to start a command, to get the state of a service, not to start a command, to start a service. Let's have a look at a service here. Let's take the service sshd, and I want to see the state service sshd status. And you see the SSH service, the OpenBSD secure shell server, is active, is running for, and so on, and it contains of these processes here. Yeah. And if you want to restart a command, if you want to stop a command, if you want to start a command later on again, then use the service tool too. Yeah. Let's say I have a service here. The service is called Squid. It's a proxy server. Let's have a look at the status for the service Squid. It is running. Let's stop the service. Service Squid stop. Oh, I need to be root to do this. Yes, so call service Squid stop via sudo. And it doesn't take some time to stop the service Squid. Yeah, service Squid needs really sometimes a long time to stop. This is a web proxy service, and it takes so long because it tries hard to not break user sessions, web sessions for the user. Yeah, so it waits for every session that goes over this proxy server to terminate first, and then it stops the service. Okay, so I have stopped the Squid service. I can see this with an output of service Squid status, and you see it's currently active, inactive, dead since. Yeah, 22 seconds ago we have stopped this, and let's start Squid again. Start. Okay, we are here on the system, and the first process on the system is the systemd. If you are on a system that is a little bit older than the year 2015, 2014, for instance, yeah, then you would have a different first process on a system, a different init system running. You would see the system5 init, yeah, just to name it, the system5 init. And a few years ago, most distributions made the switch from this old Unix init system, from the system5 init to the systemd init system. Yeah, and the switch is not this easy, yeah, because every service component, every tool or many tools on the system relies on knowing how services can be controlled. Yeah, and if you just switch the init system on a Linux distribution, it is really hard for the software developers, and therefore the systemd let you control the services the same way the system5 init system let you control the services via the service tool. Yeah, the service tool is, I would say, a legacy tool for controlling services. If you are on a modern system and this modern system has the system daemon as the init system, then you have a tool for controlling the services called systemctl. Yeah. Just have a look if you have a systemctl on your system and you know if you are on a system based on systemd. Yeah, just have a look if systemctl works on your system, and then you can have a look at the state of a service. Squid. It's again hard to talk and type at the same time. Systemctl status squid gives me the state, or will give me the state of the squid service here. You see the difference? Service takes first the service name and then the thing you want to do with the service. Systemctl first takes the thing you want to do, the action, and as a second parameter, the service you want to do the action with. Yeah. Again, I need to be root to do most of these things, so let's start systemctl directly with status and with sudo. Yeah. Okay, you see again within the output, this is the state of the squid process here. Yeah. And systemctl uses for printing out the state the tool less a pager. Yeah, so I am here within the pager, I can scroll through the output, and if I want to go back to my terminal, I simply have to leave the pager to terminate the pager. You can do this by hitting Ctrl+C, or you can do this by just hitting Q for quit. Yeah, hit quit, and the service and the systemctl tool, or the less tool, the pager that shows you the output of systemctl, terminates. Yeah. Typically, systemctl or service will be used by you if you have reconfigured a service. Yeah. Let's say I have reconfigured the service squid. I could do this by just editing the config file. Yeah? I have a config file for the squid. It is here, etc squid.conf, and then I edit this file, do some modifications, and then I want to apply these modifications. And if I want to apply these modifications, I need to restart the service or to reload the service. Yeah, and let's do this with the service command here. Yeah, sudo service squid reload if it is implemented for this service squid, and yes it is. If not, we would get an error message that reload isn't implemented here, and sometimes reload wouldn't be enough. Yeah, then you can restart a service directly. Because it takes a lot of time, I don't call it here. I simply hit Ctrl+C to terminate the command line. Yeah, but I want to give you the command line how to restart a service, how to reload a service. Yeah. Okay, so service is the tool that gives you a handle for controlling the running services, but service is more a legacy tool. On modern systems, you have service, this the tool service installed for the sake of compatibility with the system5 init system. On modern Linux systems, the tool systemctl will be the tool you need or you take typically to reload, to stop, to start, to enable, to disable, and so on a service. Yep. Okay, so this was the tool service. Service can be used to control services, stop them, start them, and so on. Okay, we have some time left, or I have some time left today. So let's take a third tool here. By the way, if you're interested in such tools we are talking today about, or we talked about yesterday and so on, have a look at the Shell Toolbox. All these tools here, these tools within tools.txt are taken from the Shell Toolbox. Shell Toolbox is a book I've written where I explain all these tools, all these single tools. You have a short explanation for the tools. You have example calls for these tools. Shell Toolbox contains all the tools you need for your day-to-day work at the Linux command line. Let's have a look at a third tool here. Let's clear the output and let's call choose tool the last time for today. Mixing the tools, and the winner is now gzip. Okay, let's have a look at gzip. Gzip is the tool for compressing, for decompressing something. And this something can be a file, or this something can be a data stream. Sometimes it can be really useful to compress a data stream if you wanna feed a data stream over the network to a remote system, for instance. Then sometimes it can be really useful to compress this data stream before sending it over the network and then decompress it on the other side. So gzip can work like most or many of the other tools. Gzip can work with the standard input-output data stream, with data streams, or gzip can work with files. The most simple way gzip works is to work with files. So let's have a look. Let's go into this directory. I have here some files, and they are really small. No need to compress them. Okay, let's take this large file here. Within the project directory, let's take this large file with a size of 501 megabyte. And now I want to compress this file because I want to save some space. So let's do this. And it's as easy as calling gzip with the file name. Gzip large file. Now it takes some time for compressing the file. Not much time. And now let's have a look. Now the file is compressed. The original file isn't within the directory anymore. The file was replaced by its compressed version. And the file now has a file name extension .gz. Okay. What's the size here? We have 497 kilobytes. The original size was 500 megabytes. This is because the large file contains mostly zeros, byte-wise zeros, and therefore it can be compressed this great. If you want to decompress a file, just use gzip again with the -d command line switch for decompress. Gzip -d, and then your compressed file. Again, it takes some time, and then the compressed file, the formerly compressed file, will be replaced by the decompressed version of the file. You see here the 501 megabytes. Really easy to use this gzip tool in this way. A small pitfall here, if you have a compressed file. Let's compress the file again, gzip large file. And now let's rename this large file to something else. rename, move large file to large file something, for instance, or just without any extension. Yeah? I just wanted to remove the extension here to show you that if I want a gzip-d a large file.something, yeah, then the gzip says unknown suffix ignored. Yeah. Typically, file name extensions doesn't matter at all on a Linux system. Yeah? But the gzip tool is a tool that by default has a look at a file name extension, and if the file name extension isn't gzip, then it won't decompress the file. It won't try to decompress the file. Yeah? If you have such a file here, yeah, with an extension you don't know, or perhaps without any extension at all, yeah, and you want to know what the type of this file is, what's this for a file, do I need to uncompress it, you can use the tool file for having a look into this file, for analyzing this file and giving you an idea what's this file or what the content of this file is all about. Yeah. So let's have a look with the file tool at a large file, and it says large file gzip compressed data. Right, gzip compressed data, and the original name was large file. Yeah, last modified and so on. So we can simply now, if we know this, we can simply move large file to large file.g. Set gzip, yeah, and then unzip gzip-d decompress this tool. Yeah. There is a different tool available for unzipping these files. It's called gunzip. Yeah. gunzip is the same as calling gzip-d. Yeah, it's exactly the same. And just for demonstration or for illustration here on this command line, I have terminated this command line gunzip or gzip-d, doesn't matter which way you use, the result is both times the same. Okay, gzip can work with files in a way I showed you, and it can work with data streams. So if you have a data stream, for instance, the output of the tool echo hello world, yeah, this is a data stream. It's a tiny data stream, yeah, but imagine you have a really huge data stream and you want to do something with this really huge data stream. You can simply pipe this data stream to the gzip command. The gzip command takes the input data stream, compresses it, and prints it out to the output. Yeah. Gzip says me that compressed data not written to a terminal, because the compressed data may contain some control characters that disturb my terminal layout or something like that. If I want to do it this way, this is the solution. If I want to show you the compressed data stream, use the -F to force here. And you see, really, this is hello world compressed. Yeah, it's not shorter than hello world, yeah, because we have some headers and so on. Yeah, this is only a tiny data stream. It's not always a good idea to compress such tiny data streams. Yeah, but let's say the data stream is a little bit bigger. You have more data to transfer. Yeah, let's say I call sudo to catch diff. Oh, I wanted to print out my disk. But I have forgotten the name of the device file. Yeah, so via sudo, I can use the cat command to print out the binary data of the disk. It's not really efficient to do it this way, but for demo purposes here, and I can just gzip this data stream, and then I could do something else with the data stream, with the compressed data stream that comes out from the gzip command, and just pipe it to the next command to send it over the network, or just redirect it to a file. Yeah, disk image.gzip, for instance. Yeah, this would be a way to create a compressed image, yeah, of my first partition on the system. Yeah. Okay, so gzip can be used to compress data and on the fly as a data stream, and it can be used to decompress data on the fly. Yeah, so if I use gzip this way, you have seen this. Yeah, this is the compressed data stream, the compressed output of hello world. If I have this data stream and I want to decompress it again, then I can just use gzip-d for doing this, and you see hello world is the result. Yeah, gzip has compressed the data stream, gzip-d has decompressed the data stream. Okay, this is the tool gzip, simply for compressing, decompressing gzip compressed files. If you call gzip via --help, or if you have a look into the manual page of the gzip command, then you see you can control a little bit how the compression works. You can run recursively through directories, for instance, if you want to compress every single file within a directory. Yeah, gzip won't compress a whole directory into one single file. To accomplish this, you need to use a different tool, tar for instance, to build an archive of files and then compress it later on. But you can call gzip just to go into a directory and compress every single file it sees there in place. And you can control how the compression should be done. Yeah. If you want to have a fast compression, then the compression, then the amount of data you save will be not this big. Yeah. If you want to save the most space on the device, then take the command line option -9 here. Then it takes a little bit longer, but you save more space. I don't know what the default value here is. You can compress with -1 or -2, -3, and so on. As bigger the number goes, as better the compression is. Yeah? And as lower the number is, as faster the compression is. Yeah, I think the 5 is the default value, but I don't know it exactly. Yeah. Okay, so this is the gzip tool. If you have any questions, put them into the comments here. Okay, and if you're interested in more such tools, have a look at the Shell Toolbox. Yeah, it's over now for today. Have a good time. See you the next time.